Hello everyone. I am Ding and I'm from Intel. I'm a machine learning engineer in Big Data Group. In this session, I will talk about our work about scalable AutoML for time series forecasting using Ray and Analytics Zouwu. This is the agenda of this session. First, I will introduce the background, and next, I will talk about the scalable AutoML for time series on Ray and Analytics Zouwu, and at last, I will share our user case and learnings. Okay, first, let's come to the background part. At Intel, we have been focusing on building various of technologies to bring AI to big data. We have open source BigDL, which is a distributed deep learning framework. And we also developed a high-level unified analytics and AI platform on top of the deep learning frameworks like BigDL, TensorFlow, and PyTorch. With Analytics Zouwu, we can provide an end-to-end unified pipelines to our users. This is a high-level overview of Analytics Zouwu stack. As I mentioned in last slide, Analytics Zouwu integrates the low-level deep learning frameworks like TensorFlow, PyTorch, as well as the distributed frameworks like Ray and Spark. Analytics Zouwu can be run on your laptop and without any code change. It can seamlessly run on your large cluster to process your production data. Basically, there are three layers inside the Analytics Zouwu. At the bottom layer, we have an end-to-end pipelines layer. It allows users to apply their deep learning and AI models to a large cluster in a distributed fashion. For example, a lot of users are running distributed TensorFlow on Spark in Analytics Zouwu. And on top of the end-to-end pipeline layers, there is an AutoML workflow layer. It helps users to automate lots of manual tasks. And on top of the workflow layer, we provide a set of built-in models and algorithms for recommendation, time series, computer vision, and NLP. Also, user can run any standard TensorFlow and PyTorch model and transparently use Analytics Zouwu to scale out their AI models to big data cluster. So what's time series forecasting? The problem can be defined as given all history observations from Y1 to YT, we need to predict the values of next h steps from YT plus 1 to YT plus h. Although in theory, we can use all history T observations. Usually, we only use the previous k steps, which is often called as looking back period. There are various approaches to solve the time series forecasting problem. For the traditional methods, we have autoregression, exponential smoothing. They are relatively simple, but are not very good at capturing the complex temporal relationships across time series. And recently, machine learning and deep learning methods are becoming more and more popular. These new machine learning and deep learning methods are usually data-driven, and some deep learning methods that have been used for sequence modeling has been applied to time sequence, such as LSTM, GRU, and attention. The machine learning and deep learning can outperform the traditional methods. It has been proven in several well-known competitions and real-world applications. Although machine learning can do well in the forecasting problem, it's not an easy job to train a machine learning model, especially if you are not experienced in the field. And that's why AutoML has gained popularity. The purpose of AutoML is to make it easier and more efficient to build a machine learning pipeline. It can automate various machine learning stages, such as feature engineering, model selection, optimization, and evaluations. Also, AutoML can be used to do the hyperparameter searching. In Analytics Zoo, we have chosen Runtime as the backend to implement the AutoML support. And Runtime is a library on Ray for scalable experiment execution and hyperparameter tuning. And Ray is a distributed framework for emerging AI applications. Ray on Spark is a feature in Analytics Zoo. It's designed to run your Ray program on Spark cluster. So with Ray on Spark, we can run our AutoML solution on Spark cluster, and the user does not need to care how to manage the two data frameworks. That's all about the background. And next, I will introduce the scalable AutoML for time series on Ray and Analytics Zoo. This is an overview of time series support in Analytics Zoo, and the time series solution is highlighted in yellow. At the bottom part, there is the general AutoML framework. It provides abstractions of machine learning stages, such as feature generation, model selection, and hyperparameter tuning. And on top of the general AutoML framework, we have provided built-in algorithms and methods specifically for time series problems. We have anomaly detection and forecasting, and the users can build their time series applications on top of these supports for their various scenarios. And as shown on the right side, there are three features in our solution. First, we have rich models and algorithms. And second, we have AutoML support. It can automate the feature generation, model selection, and hyperparameter tuning. And last, we provide seamlessly scaling our AutoML solution to your big data cluster. Let's dive a little bit into the software stack. In our AutoML framework, there are four major components: the feature transformer, the model, search engine, and the pipeline. The feature transformer and model can be considered as black boxes, which takes in hyperparameter configurations to construct the internal pipeline and control the execution process. Specifically, the feature transformer can be used for feature generation, rescaling, selection, and so on. And for the model, it can be used for single model training and multiple model selection. The search engine is responsible for generating hyperparameter combinations, and we have implemented a Runtime search engine to enable the search capabilities on top of Runtime. When it will spawn the trials and schedule and keep track of the trials across the Ray cluster, and when all trials ends, the results of all trials will be retrieved, and a pipeline will be constructed from the best hyperparameter and the trained model. On top of the AutoML framework, we have implemented a class named Time Sequence Predictor, which can use to generate the automated training process. And we also implemented a class named Time Sequence Pipeline for the pipeline output. The pipeline can be saved to files and restored later for inference and incremental training. This is an illustration of the training workflow. We can see the search engine drives the entire training process. At construction time, it will take in the feature transformer and the model. It will also take in search presets. And at the runtime, the search engine will generate different combinations of hyperparameters based on the presets. It will spawn the trials, scheduling the trials on the cluster, and each trial will run a different hyperparameter combination. When a trial ends, it will write its results into the HDFS, and when all trials end, the results will be retrieved from the HDFS, and a pipeline will be constructed from the best hyperparameters and the trained model. Here is a glimpse of the API. To train a pipeline, we first created a time sequence predictor, and then just call fit on it to launch the automated training process. For the fit function, there is a parameter named recipe, which used to configure how to do the hyperparameter search. In Analytics Zoo, we have provided several kinds of recipe for your convenience, but you can also implement it your own. And there is another parameter named distributed. It's indicated to whether to run on a single node or the cluster. And the fit function will return a pipeline. The pipeline can be saved to file and load back later. Also, the pipeline provides APIs like evaluate, predict, and fit, and the fit is for incremental training. So it's very easy to use the APIs to build end-to-end pipelines. Next, I would like to introduce a new project that built on top of the AutoML time series in Analytics Zoo. The name of the project is Zouwu. Project Zouwu is created specifically for telecom. In Project Zouwu, we have AutoTS, which have AutoML support for building end-to-end time series analysis pipelines. And in Zouwu, it also provides built-in models for time series analysis without AutoML. And we also have reference time series user cases in Zouwu. You can find more details about Zouwu in the bottom link. Okay, next let's come to the last part, user case sharing and learnings. In Project Zouwu, we have reference time series user case, the network traffic KPI forecasting. In the user case, we have used aggregated traffic KPI, such as total bytes, average rate, as example targets for forecasting. We use the data in the past week to forecast the KPI in the next 2 hours. We have provided 2 notebook examples to show how to use Zouwu API to solve the forecasting problem. In one notebook, we use the built-in forecaster models, and in the other notebook, we use AutoTS, which has built-in AutoML support. And if you are interested, you can find the details about the example notebook in the links. This is a real user case. We previously collaborated with SK Telecom for time series-based network quality prediction. SK Telecom want to do the KPI forecasting to identify the potential abnormals in their cells and base stations. And then they use them to generate alerts in their 3-dimension map. We have a talk about this user case in the Spark Summit, and you can find more details about the user case in the bottom link. Another user case is Newsoft. We have worked with Newsoft to build a forecast-based analysis for AI ops. In their intelligent AI ops system, they want to use the KPI forecasting and the abnormality detection to monitoring the metrics for their DMS and their service. In this user case, They use our AutoML solution to build a pipeline, and then they achieved a desirable accuracy in a very short time. Okay, last, let's talk about the future work. We have been working on solving the problem of extremely high dimension time series forecasting, and we also plan to improve the search algorithms. We are adding more models and features based on our customers' request, and we are also considering adding adding the automatic data pre-processing to improve the data quality, especially the missing data value. Okay, that's all my talk. Thank you very much.